Hey everyone, welcome to the Naughty Samurai channel. Today's video will be based upon the concept of outliers. After this video, you will be able to explain what outliers are and how to detect and handle them. An outlier is a value that lies outside the normal range of the data. They are significantly different from the rest of the data in the dataset. As its value appears to be far away from the other observations, they can distort the overall results or predictions. Suppose you have this test scores. Among all these scores, 99 stands as an outlier because it's much higher than all the other scores. Why outliers matter? Outliers can skew averages and trends. These skews in the dataset might indicate errors in the data entry, or it may highlight some other important discoveries such as fraud or disease detection. Mostly while handling the dataset, outliers are particularly removed, but it's not always that case. Not all outliers are bad. Sometimes they provide critical insights depending on the context. For instance, a genius child in a class of average students. Now the question that comes up is how to detect outliers. The outliers can be detected applying any of the following three methods. The first is the box plot method. In this method, a certain range is maintained where if the values exceed the product of 1.5 and IQR, then they are considered as outliers. The second method is the Z-score method. If a data point Z-score is greater than +3 or -3, it's likely an outlier. And the third method is using visuals such as scatter plots or histograms to understand the spread of the data. Quartiles are a way to divide a set of data into 4 equal parts. They help you understand the spread and distribution of your data, especially where the middle values lie. So here, Q1 is the first quartile. It is also known as the 25th percentile, which means that 25% of the data falls below this value. So here, starting from here up until Q1, we will have 25% of the total data. And next in line is Q2, which is also known as the second quartile or the 50th percentile. That means that 50% of the data falls below this value. So starting from Q2 up until here, we will have 50% of total data. Alright. And next is the Q3, which is known as the third quartile or the 75th percentile, which means starting from Q1 up until here, we will have 70% of the total data. So this will have 75% of total data. So this whole distribution is 100%. And here between Q1 and Q2 we have 25% of the data starting from 26 up until 50. So here we have 25 and the summation of this 25 and this 25 makes it up 50. In the same manner between Q1 and Q3, between Q2 and Q3 we have another 25%. So summing this 25% and this 25% makes it a total of 50%. So between Q1 and Q3, we have a total distribution of 50%. So this is 50. And again, after Q3, we have the rest of the 25% portion of the data set. So we will write 25%. And now if we sum all these 4 portions up, like as they are divided in quarters, so it means that this portion has 1/4, this portion has 1/4, this portion has 1/4, and the very last one, this portion has 1/4 too. So if we sum it all up, it gives us a total distribution of 100%. As Q2 acts as a bisector here, which means that on the left side of it lies in total 50% of the data, and again on the right side of Q2 lies the other 50% of the data. So Q2 acts as the bisector here, and as it acts as a bisector, Q2 can be considered directly as the median value. I hope you guys understood the concept behind quartiles and how they work. They are just super helpful into understanding the distribution of your dataset. As we are already done talking about the quartiles, now let's dive into the concept of IQR. So what is IQR? IQR stands for interquartile range. It is a measure of the statistical spread and it shows the range between the first quartile and the third quartile. The formula for finding out the value of IQR is Q3 minus Q1. I'm telling it to you firsthand because as I've explained you the concepts of quartiles, I'm guessing you might have already understood or grasped the concept behind finding IQR. But if you did not, it's totally okay. I will take a hands-on approach into explaining this. Q1 is known as the 25th percentile and Q3 is known as the 75th percentile. So here what is happening is that if you notice, the bold line in the middle is the median value, and as we know, we saw that Q2 is the median here, so we can mark it as Q2. Alright, I'm taking the pen and I'm going to write Q2 here. So, as per this figure that we understood over here, the total distribution between Q1 and Q3 was 50%. So, as this is Q2, between Q1 and Q2, the total distribution is 25%, and between Q2 and Q3, the total distribution is 25%. So, it sums it up and makes it 50%. So as per the formula, which is IQR equals to Q3 minus Q1, it's talking about the 50% of the data set which we have over here. So whenever we are told to find out the value of IQR, we are just being told to find the difference between Q3 and Q1. Alright. So now you know that you can easily find the value of IQR if the value of Q3 and Q1 is given. And you can also actually fetch the value of Q3 and Q1 with any dataset. I will show you practically, but before going to that, let's delve into that how we can detect outliers using the concept of IQR. So I will write an equation over here. It will help you understand how to detect outliers using this graph. So this is the equation, and it tells that if the value is greater than the summation of Q3 with the product of 1.5 and IQR, or if the value is less than the product of 1.5 and IQR subtracted from Q1, then it is an outlier, which simply means that imagine let me take a pen. Let's take a marker. The color would be pink or green. Okay, so imagine like we have a value over here. Will this be considered an outlier? It won't be, because we are given a specific range over here. This is the range, which is Q3 plus 1.5 into IQR, and this is the range on the negative side, which is Q1 minus 1.5 into IQR. This point over here is within the line. This did not exceed the range, so this won't be considered as an outlier. Let's draw another point here. Is this an outlier? It's not an outlier because it's again within the range. But now if we place this dot over here, suppose the data is here, then will this be considered as an outlier? Yes, it will be considered as an outlier because it exceeds the range. This is the range. So as our dot exceeds the range of Q3 plus 1.5 into IQR, it will be considered as an outlier. And same goes on the left side. If the value is here, it won't be an outlier. But again, if the value is here, here, or any place outside this range, then it will be considered as an outlier. So we actually need to take all the values within this range, and any other values that crosses this range or this range should be dropped, and that's how we apply the concept of IQR for detecting the outliers. Alright, I really hope that you guys understood the concept that how do we apply IQR for detecting outliers. And now, as we have already understood the theory part, let's get into its application. We start by importing all the necessary libraries that are needed. Then we download the dataset directly from KaggleHub. I would be attaching the link to this dataset in the description box below, so do check it out. After importing the libraries, we will fetch the file out and we will print the last 10 rows of our dataset. Our dataset have numerous columns starting from loan ID, gender, married, and there are a ton of it. So now what we want to do is we want to fetch some information out regarding our dataset. So for that we write the data.info command, we run it, and here you can see that it gives out the total non-null count for each of the columns, and also it also explains the data type for each of the columns. Now, as our ambition is finding out the value of IQR, and for finding out the value of IQR, we need to find out the quartiles. And why are we doing that? We are doing that because we want to detect the outliers and drop them. So before getting to that, we have to fetch out some information regarding our dataset. We will write data.describe command. You will see what it does. So when we run it, it will give you numerous values surrounding our dataset. So you can see you have the count value, you have the mean value, you have standard deviation, the minimum value of the dataset, the maximum value. There is 25%. This is the 25th percentile, or Q1 as we know. This is 50% or the 50th percentile, or the Q2 value that we will need, and this is 75th percentile, which means Q3. So we have all the values for all the numerical based columns. You will see that we do not have all the columns here. We only have those columns whose data type is float or int and not object. Alright, so how can this description of regarding the dataset help into identifying outliers? So first, let me give you an idea that how can we detect the presence of outlier here. Let me give you an example. So imagine we have a list, we name it LST, and the elements inside it are 5, 6, 7, probably 4 again, 5 again, 6, 8. I think that's enough. Alright, so now we will take the mean. Mean means average. So mean sum of the list by length of the L1. Sorry, I mean length of the LST. Now we print the value of mean 1. Alright. See, it gives the total average value of 5.875, which is fine. Like, the elements all range from 4 to 8. So 5.875 is right in the middle. So the mean is 5.875. But now, like as you can see that the value is within the range of 5 to 8. It means the value is not stretched. I mean, no value is actually stretching the mean towards it. But like, what if there is an outlier here? Here in this data set, we do not have any outlier. So let me write it over here. We do not have any outlier here. Now we will create another data set. We will just copy it and paste it over here. And at the end of it, we will write 100. And we will just run the exact same thing. We will copy it. We will paste it. And let me rerun it. Now you can see that the value of mean has stretched a whole lot towards 100. Before it was 5.875, but just for the addition of this single value, which is 100, our mean changed from 5.875 to 16.33. So it is being stretched towards this value, this 100. If we increase it to 200, you will see that the value stretched a bit further. So now it's 27.44. It's further away from the actual mean value. So here this 200 or previously 100 acts as the outlier because it's stretching the actual mean value away from its average value. So I hope you guys understood like how do we actually detect the presence of outlier. Now what we can do is we can actually apply the exact same concept into this description of the data set. Let me go with this applicant income first. Alright, so here you will see that the minimum value is 150 and the maximum value here is 81,000. So if we have to make a guess, the average value of it should be around, I think, 40,000 or so. But here you will see the mean value is just 5,403. It's very, very less. I mean, it should be around 30,000 to 40,000, but it's just 5,403, which means there is a presence of outlier in that data set over here. I mean, in the applicant income column. That's how you like detect outliers. So as you can see that the value of this mean is stretched away from the real value. The real value should be around 40,000 or 30,000, but it's 5,403, which is a lot less. So we actually detected the presence of outliers here. And let's apply the same analogy into this column, which is the co-applicant income column. Here you will see the minimum value is 0 and the maximum value is 41,667. So if you take the mean out, the actual mean should be around 20,000 or so. But here you can see the mean value is just 1,621, which is again quite less. It's being stretched towards one side, actually on the left side towards 0. So here you can also say that there is some presence of outliers over here. So this is how it works. We can, like, by taking a glance on the data set using this method over here, that is data.describe, you can actually check out the columns and you will know if there is any presence of outliers or not. Alright, so now let me show you another concept which will help you understanding the presence of outliers. So what we will do is we will take a box plot diagram in order to understand the presence of outliers. Alright, so SNS means Seaborn Library, SNS.boxplot, and within X, let's take any of the two columns that we studied about, applicant income or co-applicant income. I'm taking co-applicant income. So co-applicant income, and here we will have data is equals to data. And now let's plot it. Alright, when we run it, we will get the value in a short while. Okay, so here is the box plot diagram. Here you will see that all these values are actually the outliers because they are distributed. I mean, they are not dense, they are distributed outside. For example, we had this 200 here, See, all the usual values are dense together, but there is always this certain value that is stretched out far away from the values which are all dense. So all these are the outliers. This like box plot diagram helps you understanding the presence of outliers, and as you can already see that all these values are dispersed. This one is an outlier, this one is an outlier, this one is also an outlier. This can be also considered as outliers, but they are more dense. I mean, they are not far-fetched like these values. So this diagram actually helps you understand the presence of outliers. There is another diagram that will help you understand the presence of outliers, which is known as the distribution plot. So let me plot it to distribution plot. This is more of cross-checking the presence of outliers. Alright, now what we'll do is we will take the Seaborn library again, and within parentheses there will be co-applicant income, and let me run it. plt.show. This should work. Okay, we have the diagram here, and see, if there was no outliers here, it should have been just a usual reverse U. But you can see the values are stretched away from the reverse U. It's going up until here. So it also signifies that there is some presence of outliers that is present within the data set, and we have to deal with it. So we have learned two concepts in order to deal with the outliers and how do we drop that. The first one was, let me rewrite the formula that will help you understand the concept a bit better. So the first one was, if the value is greater than Q3, okay, Q3 plus 1.5 into IQR, and the other one is Q1 minus 1.5 into IQR. This is the formula. We also saw that here you can see that if the value is greater than Q3 plus 1.5 into IQR, or if the value is less than Q1 minus 1.5 into IQR, it is considered as an outlier. It means that the value should be within this range. If it exceeds this side or this side, then it will be considered as an outlier. Now let's apply it over here. Okay, let me comment it out. We will go to the next cell, and here we will write IQR is equals to Q3 minus Q1. This is the formula for finding, here's a typo again. Alright, so this is the formula for finding out the value of IQR. Now what we have to do is we have to fetch the value of Q3 and Q1. We can do that from this, like this Q25th person value. As we are working with the co-applicant income, the Q1 for it should be 0, and the Q3 for it should be 2297.250000. Alright, let's fetch the value out. You go to the next cell. We won't run it for now. Q1 is equals to data co-applicant income and we will write 0.25 within the parentheses. In the same mannerism, we will find out the value of Q3, data co-applicant income dot quantile 0.75. Now let's run both. This should work. It's taking a good amount of time. Okay, it ran, and now we will copy it again. Let's delete this cell, take another cell and paste it. Alright, this ran as well. So let's find out what the value of IQR is.
The value of IQR is just 2297.25. Alright, now let's set the range. We know the formula. This is the equation that we need to implement. So this is the minimum value and this is the maximum value. So let's write minimum val is equals to Q1 minus 1.5 into IQR. This will be Q1. And in the same manner, max value would be Q3 plus 1.5 into IQR. And now we will fetch this values out. Let's run it. Alright, so the minimum value range is minus 3445 and the maximum range is 5743. This is done, and now you just have to apply this mean and maximum value to your data set and your outliers will be dropped. Now let's create a new data set. Our initial name of our data set was data, so let's write new data, and within data there would be like this would be data again, and applicant income. This will be greater than minimum value, and again at the same time this is it. Alright, now we've run it and the new rule should be applied. And now when we again check out our box plot, we will see that most of the outliers have been removed. So this is our box plot, x equals to co-applicant income, and within data there will be data. It will be new data and not data. So finally we will just plot our graph. And when we run this, alright, now you can see that we have a new box plot graph, and you can see that most of these outliers have been dropped. Now there are no such far-fetched values and most of the values are now condensed.
So this is it for today, guys. In the very next video, we would get into doing the exact same thing, that is we will detect outliers and drop them, but this time using Z-score. Do subscribe to my channel and like the video because your engagement means the world to me. Until then, keep your mind sharp, your code clean and stay sane. The Naughty Samurai signing off.